Welcome to part 1 of Competency 10. In this video, we will work with similar triangles. Before we begin, let's look at the properties of similar triangles that are listed. If you're unfamiliar with any of these properties, please go online, watch videos, look at old notes as I've suggested before. So these are the 6 things that you really need to focus on in all of their elements. That's understanding corresponding parts of triangles. That means corresponding angles, corresponding sides, and their proportionality, ratios of area, and also not just a ratio of the area. We're talking scale factor. That means scale factor for just a single dimension or scale factor as far as area. And then later on, we'll just also within videos, we'll talk about volume. Okay. And then remember, how do we know that two triangles are similar? Well, we need to look at all of the angles if we have them and we can compare them. That's one way to compare. And then you have side, angle, side. That is literally an angle sandwiched in between two sides, okay? You'll be looking at adjacent angles to adjacent sides. Then side, side, side. If you have 3 sides, you have not just, you have congruency, not just similarity, okay? But you have to know about these properties and understand how to use them. Like I said, if you're unfamiliar, stop the video, go find some material, your notes, and brush up a little and come back and watch, okay? All right, let's continue. Number 1, given that triangle ABC is similar to triangle DEF and AB to DE equals 5/2, what is the value of EF to BC? Okay, these are ratio comparisons and they are giving you a ratio, but let's analyze the given ratio. They say AB, okay, it's right here, to DE. So they're telling you how to correspond them. So obviously AB is 5 and DE is 2. So that's telling you we have the larger to smaller triangle. So I'm going to say large to small. Okay. Now let's look at the question itself. It is saying EF to DE. Well, things change there. That's a ratio of small, okay, EF to BC. So that's small to large, okay? The ratios from each of these corresponding sides, as you should know, stays the same. However, you can go from the small to the large and the large to the small, and that's when we talk about scale factor, correct? So this means for the question itself, we have small to large, and that means we have 2 to 5 as our new ratio. Okay? All right, let's look at number 2. Okay, and you know what? Talking about number 1, that seems very simplistic, right? And not rigorous. There will be questions like that on the test. They all have different weights. So think about what they ask you. They're asking you about how to define. You have to know how to define similar triangles. You have to understand the ratio, what they tell us. So it isn't just about the numerics of it, it's about the definitions and the comparison, and you have to know the properties, the definitions, properties, as well as how to deal with the numbers, okay? So don't think you won't have some of these more or rather less rigorous questions, okay? So be prepared for them. All right, so let's look at number 2. Use the information from question 1 above. Let AX represent the median of ABC and DY represent the median of triangle DEF. Okay, so that means we need to take a good look here. I put it, let me bring it down just a smidge more. Sorry about that. Okay, so there we go. So now let's erase some of this highlighting so I can just highlight again. So we're talking about, they're saying if dy equals 7, okay, that's on the smaller one, okay? And what is the value of AX? And that would be the larger triangle. Okay, and if you haven't already figured it out, these are not drawn to scale. Okay, so let me put my 7 here. That's my 7. Okay, all right, so let's do this setup. And they're saying to use the information from number 1. Well, that's where they gave us our ratio, our scale. Okay, so we need large to small. Okay, that's a S, large to small. And we had 5 over the 2. Now our question says, let's look at those median distances, right? That's what it's telling us to do. Okay, fine, I'll look at that distance. For the large, we don't know. That's just I don't know X, right? Okay, but for the small, they did say, hey, you have 7. All right. Now, let's talk about the ways we could put this in the calculator. Okay, we could do that traditional cross multiply, divide by the coefficient. That's what we tell our students. Okay, fine. Let me set that up. That means x equals 5 times 7 over 2. Okay, and you could probably look at the answer. There is another thing I want to introduce, and I've used it in other videos. Just open up your mind if you had a generality. Let's say x changed. Maybe, something's different. My x values can change. My ratio's the same, but my x is different. Different. I know it seems, far-fetched, but let's do that what if. So 5 over 2 minus x over 7. Remember, they're said equal to each other. So if I subtract them from each other, I have 0. Okay? So first, let's calculate the answer. Fraction, 5 times 7, arrow down to, voila. It solves it for me. It's in the calculator, but use your toggle button. Option D. There we go. Now, let's take another look at table. Push table, clear it out. Okay, put it in exactly this other form I have it in. I've created into an actual equation. Okay, simple, but still an equation. So fraction, 5 over 2 minus another fraction, and x, because we don't know what it is, and then go down, 7. Okay, now let's push enter. And I am going to use ask. I have 0, 1, and I'm going to go over here and use ask and enter each of my options. So enter again. There you go. Now, this is old info, so you want to get rid of that. Go up. Remember, you only have 3 lines to work with, but it will type over for you. So 15, enter. Obviously, not 0. Remember, for my y value, it needs to be 0. Okay? 15.5, enter. No, that's not 0. Okay, so let's just do 17. Not 0. All right, now I'm going to go up to the top. Delete that out so it's fresh, okay? And let's put in 17.5 and enter. There we go. There's our 0. So D is verified. Now, this is a way to graduate students from the proportionality to the linear concept, okay? Just another thought of a way to enter it in the calculator, okay? All right, so let's go to number 3. Number 3, given the ratio of corresponding sides is 2 to 5 and the perimeter of ABC is 12, what is the perimeter of triangle DEF? Okay, we're still working with the same triangles and the fact that they're similar. And we knew from the other questions that DE is 2 and AB would be 5. Okay? So first I want to note that we're talking about perimeter. This means that our scale factor, our ratio of corresponding sides, is a scale factor. And when we're dealing with perimeter, we use it as is. So that means that we have the smaller triangle over the larger one, and we will compare 2 over 5 equal to the smaller one, we're looking for it, so that's x, and the larger one would be 12. Okay, now we know what to do. We have two ways to do this. Okay, we could find x by doing the traditional proportion. Multiply 2 times 4, then divide by 5. Okay, we have that. Or we could say 2 over 5 minus x over the 12. Okay, there we go. Over 12 and make that equal to 0. Okay, so first let's use our fraction. That kind of, that was strange. I guess I'm going faster than my computer can catch up. Okay, so first let's use our fraction and do the first one. Okay, that is multiplying. That's my highlighted. 2 times the 12 and divide by the 5. Let's push enter and then toggle. Okay, and that gives us option C, a 4.8. Now let's verify it using the table method. So push table, clear out what's there, and then I have my fraction, 2 over 5, arrow all the way over, subtract. We have another fraction, and that is x over the 12. Push enter, and we will ask for each of our options to verify. Okay? All right, so let's go enter, enter, and enter. And I like to go in order if you haven't figured it out. So let's delete each of these. Okay, now go back up. So 5.5, enter. No, obviously that won't work, which is good for us. So then enter, no. Okay, now this one should work. 4.8, enter. Yes, it does. And I'm going to go up and try 4 again. Okay. All right. Nope. 4 will not work. So we verified the answer that we got. Okay. All right. Now let's look at number 4. Given the ratio of corresponding sides is same ratio. Okay. And the area of ABC equals 100. What is the area of triangle DEF? Okay, this is area, and that means that our scale factor must be adjusted. Okay, an area is a square. That would be square inches, square feet. That's the implication of area by definition. So we will have to square our scale factor in order to find the area. Okay, so I'm going to put it in the table, and I'm going to kind of skip some steps here. I'm going to erase that equal, and going to say I'm subtracting those two and setting them equal to 0. So I can use my table method. Okay, so let's clear. I'll just go back by clearing. Okay, it's best. You can type over if you want, but I think it's better in this case that I don't. So open parentheses, fraction again, 2 over 5, go over, close parentheses, and then square. Okay, now subtract another fraction and x over the 100. Verify that I have it entered correctly. I would say yes. Okay, now we will do the exact same thing and just use our options again. Okay, all right, so let's delete out these. Okay. Right now, as you notice, I'm kind of piling up my buttons here. So I'm going to clear that out so we can see exactly what I'm pushing. So let's clear it out. Remember, you can always rewind the video and see what you need to. So let's clear. I'm going to go back up. Now, let's try 24. No, That's not going to work. Okay, good. All right, let's try 32. Nope, that's not equal to 0. Let's try 40. Oh, no. Okay. All right, let's arrow back up. Delete that first line. Cross our fingers and see if 16 works. And it does. 16 is the correct value. Now, you could have used the other method, but if you do, you would have to, I mean, you could probably see what our scale factor becomes when we square it, but putting it in the calculator is a good idea if you're not sure. Say the numbers are different or you're a little shaky on your exponents. That's fine. Use your calculator. Just type it in as it is, just that part that you need, and there it gives you the 4 over the 25. Set that equal to x over 100. Well, here's very quickly, I'm looking at this. I see another way to get what we need besides a cross multiply and divide by the coefficient. You could just simply say, hey, what do I, or what did I have to multiply 25 by to get 100? Well, of course, that was 4. And if you multiply the denominator times 4, that means the numerator would be multiplied to times 4. So 4 times 4 would be the 16, correct? Or you could try it the other way. Here we can multiply across and divide by the coefficient. Any of those three ways, it doesn't matter. Get there the way you need to. Use the table if you feel like that's not, I mean, that I use a table so I don't make any basic calculation errors. That's why I do that. That may not be your thing, so don't do it if it isn't. So there's a third way, 16. Either way, we verified all of our methods. All right, let's go to number 5. Number 5, given that triangle ABC is similar to triangle DEF, which proportion must be true? Okay, this is using the same notation for the triangles. However, the triangles are quite different. Okay, but what we do need to do is pay attention to the proportion. And there's more than one way to write that. So we just have to be consistent. Let's look at this. If we say that we are going to go from the larger one to the smaller one, like this, okay, then we just need to be consistent with our proportion. So let's say we're going from 6 over the corresponding 4 must equal then from 7 to the corresponding x. Okay, that would be one way. Okay, now we could, let me get rid of this, okay, each time so it's clear. That's one way. Now we could go from triangle to triangle. Let me show you what I mean. We could say 6 over the 7 and then 4 over the x. That would also be correct. Okay, 6 over the 7 equals 4 over the x. Okay, so let's compare what we have here. So when I have 6 over 4, that means large to small, large over small. So 6 over 4 and then 7 over x, large over small. But then where I have green, that is the one side to the next side. So that'd be one of the sides over the other side. Then when we go to the smaller one, so that would be the larger triangle first, but we have to make sure that when we go to the smaller triangle, we're saying the corresponding side of the prior triangle with over the other corresponding. So we have to keep it all together. And that's a common mistake to not do that. So now let's see. Is there a third way to look at that? Yes, there is. What if we said small, then too large. Well, then that would be 4 over the 6 equals x over the 7. Okay? And there's even another way. We could say x over 4 equals 7 over 6. Regardless, let's start seeing if, no, let me write that down. We could go this direction. Stay with the small one and write x over 4 in this one. Let me write them all down so we can compare. Okay, so let's see here. That would be x over the 4 would be equal to 7 over the 6. Okay, let's look at A. A doesn't match any of the 4 that we've written. B, let's see, 4 over 6. Ooh, that matches this one. Okay, now let's look at C. 6 over 4, nope, these two are wrong right here, so that's not going to work. Okay, then 4 over x would have to be 6 equal to 6 over 7. Nope, D does not work. Yes, there are a lot of ways to write it, and there are also a lot of ways to make mistakes. You must make sure everything stays, it corresponds. Everything, no matter how you write it, that your ratios are consistent. Just once you get started, you have to be consistent. So B is verified. All right, now let's look at number 6. State if the triangles are similar and why. Okay, and then they give you rationales to choose from. Okay, when you are looking at this particular type of triangle, you know that you will have a common angle, but you cannot simply fold this triangle over. Okay, it might look like you can, but actually 24, here, let me change colors, look here. Okay, 24 corresponds with 48. Okay, and let me go with this blue. Well, if that's the case, then 8 corresponds with 24. Okay, and then we know, of course, naturally that 30 would have to correspond with 60. Okay, so the triangles are not flipped over like a reflection. No, they're actually rotated. Okay, all right. So you'll have to double check that and look at it yourself. And I think either way, even if you did it or if you flipped it over, you could very quickly see that 24 over 24 just doesn't make sense. Okay. So let's go about it the way I have it written down. Well, we know that we would have 30 over 60. I'm saying small over large. Now we have a question mark. Does that equal 24? We're going with small. 24 over the larger 48 corresponding side. And then, question mark, is that equal to? We have a last one, would be 8 over 24. If this is truly two similar triangles, all three of those ratios would be equal. So instead of trying to do it in your head, just type it in your calculator. Okay, fraction 30 over 60, that's a half. Okay, so we're starting out with a half. So these others should be a half. Let's see if it works. So fraction 24 over 48 enter. That one works, so that's a yes. So we can leave that equal. Now, let's check this last. Okay, so we have fraction 8 over the 24. And no, that is not equal to 1/3. Therefore, this is not a similar set of triangles, even though, I mean, it looks like the picture is misleading. So never trust the image. Rarely in testing, especially this type of test, are there going to be to scale? Okay. All right. So let's see. The answer is no to it being similar. So that gets rid of A and B. They're saying they're similar, and obviously they're not. So let's look at C. The triangles are not similar since the angles are not guaranteed to be equal. We don't have any information about the angles. We have one that we know has to be one set that is equal, and that's true, but we don't have a comparison. They could be. No, they're not guaranteed, but they could be. But let's look at D, just in case. The triangles are not similar since the sides are not all proportional. That is guaranteed truth. So D is what I would select. I would not select C. The reason I wouldn't select C is because there's no information given about them. Okay. And just because of the way we looked at it and solved it, and because we had to do it that way, we were given all the sides, that makes more sense. Okay. All right. This is the last question in this video. Wanted to thank you guys for liking, sharing, and subscribing. You guys are amazing. Thank you so much for continuing to support us. Happy testing, everyone.